Okay, so I think I want to get back into what a multiplicative identity is. And we say the multiplicative identity is 1. Because if we multiply something by 1, it doesn't change it. So for example, 2 times 1 is 2, 7 times 1 is 7, smiley face times 1 is equal to smiley face. However, there is one number though in our little number system where if you multiply it by 1, it's not 1. Can you think of that number? Can you think of the number? If you hit the little pause signs, you can get back to me. But there is a number, okay? And if you came up with it, it's 0. And we could talk about 0 another time because I just love that number. But anyway, what I want to do is I want to take this guy right over here, and this time I want to break it down into fifths. Okay, so by breaking that down into fifths, life is going to be like brand new, gorgeous, wonderful. So 1, 2, 3, and 4. So each one of these should represent a fifth. Okay, now if I go ahead and I wanted to make something equivalent to that, because remember what we said, we had equivalent fractions, right? 2 fifths, then technically, it's 2 out of 5. So if I were to shade 2 out of 5, I'm going to be crazy. I'm going to shade 2 out of 5 on this side, right? So this represents 2 out of 5, okay? So let's say 2 out of 5 people decided to eat ice cream. The other 3 out of 5, I hope you say, did not eat ice cream, okay? Because if you think about it, those two have to actually add up to a whole, right? So if 2 out of 5 people didn't eat something, that means 3 out of 5 people did, okay? So now if you wanted to do an equivalent fraction, right? I said to you, we could easily, now think of something, think of any number in your head. Think of a number from 1 to 10. Think of a number from 1 to 10. I'm gonna go with 6. Okay, I like the number 6. So what I'm gonna do is I'm gonna multiply this by 6. And remember what I said, if I multiply this by 6, then upstairs has to also get multiplied by 6 because technically 6 divided by 6 is equal to 1, okay? So the cool thing is I am technically taking 2 fifths and I am multiplying it by 1. And if I multiply across, I get 12. And if I multiply across down here, I get 30. So that means then that 2 fifths is equal to 12 out of 30. So let's think about that for a second, okay? If 2 out of 5 people opted to eat ice cream, that means 3 out of 5 people opted to not eat ice cream. Okay, so let me write that down. So 2 fifths ate ice cream. So 3 fifths did not eat ice cream. Not. I don't know why. I love ice cream. I would have been one of the 2 fifths people who ate it. Okay. Now, if I said 2 fifths and 3 fifths, that adds up to 1 because that's a whole. Okay. So now we're talking about 30 here. Now, this is pretty crazy. I'm going to ask a crazy question. Okay. So if 12 out of 30 people, so let's say 12 out of 30 people ate ice cream. Can you tell me who did not eat ice cream? Or how many did not eat ice cream? Or what fraction? The fraction who did not ice cream. And we know it's still out of 30 people, right? But how many people are going to give us a whole here, right? And so how many people are going to give us a whole? Now, the way to look at this is we could go ahead and break this down into 30 pieces. 2, 3, 4, 5, all the way up to 30, right? Or we know if you look over here, 2 plus 3 gives me 5, and that 5 over 5 gives me a whole. Whereas over here, 12 plus some number has to give me 30. Did you guys figure out what that number was? Because if I'm you, I would go and hit pause and see if I can find out what it was. I'm going to say 18 out of 30. So what's interesting to me is that 18 out of 30 is the same as 3 out of 5, right? And over here, 2 out of 5 is the same thing as 12 out of 30. And the reason why, okay, and the reason why is because if you look over here, right, I have 2 over 5, I multiplied those by 6 to get 30, so that means to go backwards, I would have to divide by 6 because those are inverse operations. They undo each other. Now, if you look at 3 fifths over here and you're looking at 1830, that's right, I'm going to go up top here, can I have a little space here. 3 fifths equals and I have 18 over 30. What did I multiply 5 by? What did I multiply the bottom by? And what did I multiply the top by? And if you said 6 over 6, I hope that you're like, oh my goodness, it totally works. So yeah, because 3 times 6 is 18 and 5 times 6 is 30. How cool is that? I think that's super cool. Okay, now what I want to do is I want to get into multiplying some fractions. I'll be right back. Let's say, for example, now I want to multiply, look over here, 1/2 times 3/5. What does that mean, right? So in other words, how about this? I look at it this way, like there's a half, right? Let's say that there was half of a cake left, like this delicious, like, chocolate cake. I like chocolate cake with vanilla frosting personally. So I want to know how much 3/5 of that half would be. Okay, so let's say, for example, okay, there's a half a cake, right? There's a half a cake left, all right? And right now, there's 5 people in my family, but 3 want a piece right now, okay? I need to know how much of the cake that's going to take up, okay? How much of the whole cake it's going to take up. So here's what I like to do. If it's a half, I'm going to take my half here, and the first thing I'm going to do is I'm going to cut my delicious chocolate cake in half. That's not really half. Let me just go back. I could do a little bit better than that, right? Charlie could do a little bit better than that. So a half is right about there. Okay, so that's a half here, and that's a half here, right? So half of it was already eaten. This is how much is actually left for us to eat and enjoy, okay? And I want to know how much 3/5 of that is. So what I'm going to do is I'm going to move horizontally. See how vertically I made it into half? Now what I want to do is break it down into fifths this way. So we're going to go 1, 2, 3, 4, like that. And then you'll notice it breaks it down into fifths. Okay? So the cool thing is that this is 1/5, this is a fifth, this is a fifth, this is a fifth, and then down here is a fifth, right? So if I said to us, I'm like, okay, let's go back to the half, right? So this was half the cake from here all the way down here, right? That was half the cake, right? But now I only want 3/5 of that to go to the family that wants it now. Like 3 of us want it now. Like I want it, my sister wants it, my brother wants it now. Here is 1/5, here's another fifth, and here's another fifth, right? So if you look at that, you want to ask yourself, out of the entire thing, this color right here, which I'm going to basically go over in yellow, is the combination of 1/2 times 3/5, which is this guy right here, okay? It's that right there. So if I said to you, how much of that represents the entire cake? So if you think about it, we have a total of 10 pieces here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of them are yellow? And I hope you guys are saying to me, 3 of them. So that means that represents 3/10. So if I wanted half of my cake, right? I want to take half my cake and give away 3/5 of that. That would be 3/10 of the entire amount. Now, what I want you to look at over here is take a look at this. If you look up in your numerator, which I like to call upstairs, if you look over here, what's pretty cool is if I do 1 times 3, I get 3. And if I do 2 times 5, I get 10. What? Okay, so let's try another one. I'm going to change my color, and we're going to go with, say, 3/4 times, let's get crazy. We're going to go 2/7. You ready? Okay, so 3/4. So remember, because it's 3/4, so let's say that this time there's a second cake that was made, all right? And 3/4 of it is still left over. And there's 7 people at my house, and 2 of them are like, yo, I want a piece of cake, okay? So we want to figure out how much of the entire cake that takes up, all right? So this is 3/4 of the cake left. 3/4 of the cake left. Yummy, yummy, yummy. Okay, so I'm going to go back up top again, and this time, because it's in fourths, I'm going to break the cake down into fourths now, going vertically. Okay, vertically, 3/4. That's pretty bad, Char, but we'll just have to go back. I can't. I have OCD, and I can't accept that. So you guys, what should I have done first? What should I have done first? I'm kind of glad that I did that. What should I have done first? And if you said break it in half first, good, and then break that in half, good, and then break that in half, wonderful. Then we have 1/4, right? There's 1/4, another fourth, another fourth, and another fourth. This, we have how many fourths going straight across is 4 fourths, right? Okay, and that's 1. Now, we have 2 sevenths. So this time over here, because vertically this was in fourths, now horizontally we're going to go into sevenths, right? So let's see if I can do this. Ready? Wish me luck. 1. This thing, I'm writing on a tablet here. It's so hard to. 3. Oh my God, just squeeze it in here. I am a rock star. Okay. By the way, hit pause and think about how many pieces there are total. Like if I were to cut this whole thing out, how many pieces of cake actually fit into this spot here? Hit pause and I'll come back to you, okay? Hit pause. Hit pause. Okay. If you hit pause and you came back, I hope you said that there were 28 pieces because this is, we have 1 7th, 1 7th, 1 7th, all the way down, 1 7th, 1 7th, 1 7th, and finally 1 7th. Okay, you can barely see my sevens because it's so small, but we'll manage. Okay, so if I do 3 out of 4, right, if I do 3/4 of the cake, 3/4 of the cake is all of this over here, covering every last bit. So if 3/4 of the cake is left over, how much of the cake was actually eaten? I hope you guys said 1/4, okay? Because everything's always got to add up to 1. Everything's all about the whole. Okay, I made these little pieces, they're still here too, okay? They're all supposed to be the same size, but because I'm writing stuff out freehand, it's kind of being butchered a little bit. So this is all in here, okay? So that's how much of the cake is. That's 3/4 of the cake left. Now, I only want 2 sevenths of that. So I have to go over here and ask myself, okay, since I went horizontally and broke it down into sevenths, then I'm going to come along here and I'm going to be like, okay, so I have 2 sevenths. It's right here. So it's all of this here. So if that's 2 sevenths, then what I'm not shading in is 5 sevenths, right? Because think about it. They have to add up to 1. You got to get those little numbers cooking in your head. Okay? So technically, if I go in here in orange, it's all of this. Whoops, orange. That's still green. If I do all of this, this is all orange. Okay? All of that. So highlighted in orange, you guys, how many pieces are orange? Right? And I hope you said there's 6, right, out of 28 of them, okay? It's 6 out of 28 of them are, in fact, shaded in orange. And that means that if 3/4 of the cake was left over and I only wanted to shell out 2 sevenths to 2 people because there's 7 of us, but only 2 actually want a piece of cake. This is how much cake is actually, left over, but this is how much of the cake is actually going to get eaten right now. So here's the thing. I'm a little crazy. I want you to look at your numerator and your denominator because I'm a perfectionist, okay? It's my job. 6/28, interesting. They're both even. So when they're both even, that means they must be divisible by what number? What number goes into both of them evenly? And I like to actually say divisible. And I hope you guys said 2. So if I take each one and I divide it by 2, right? That should be divided by, okay? And then 28 divided by 2, your final answer should come out to 3/14, okay? So that means that you guys should be like, these 2 fractions are equivalent because to go from here to here, I divided top and bottom by 2, and 2 divided by 2, everybody, you should all be like, oh my goodness, that's 1, and that's a multiplicative identity. Okay, it's a multiplicative identity. All right, so where am I? I'm losing my train of thought here. Where am I? Oh, this is what I wanted to show you, okay? If you look at these 2 kids over here, right? Instead of having to do this step from here to here, what you could have done was something a little simpler. If you look, there's 2 numbers that are quote unquote sitting upstairs and there's 2 numbers sitting downstairs. So I like to think of it as what we call, we can go ahead and cross cancel. So that becomes a 1 and that becomes a 2. So if you multiply across, this is equal to 3. And then 2 times 7 gives me 14. And I will go deeper into that later, or maybe I'll just edit that out because it might confuse the heck out of some of you. So, and I don't want that for you. I don't. Okay. I hope we're going to keep moving on. So I hope you guys are enjoying yourselves. If you want to, go get yourselves a piece of cake. I will be back.